So I have several properties for limits of sequences. First I have to define, so I have the limit as n approaches infinity of a sub n is L, and the limit as n approaches infinity of another sequence b sub n is k. Then I can say this. I can say the limit, the sum of the limits, limit of the sum or difference of the sequences equals the sum of each limit separately. And if I have c of any real number, the limit as n approaches infinity of that value times the sequence a sub n is c times the limit, and c is any real number. I also have, if I multiply the two sequences together, then the limit is the product of their limits. And if I take the quotient of the two, it equals the quotient of their limits as long as my sequence b sub n is not 0 and my limit is not 0. Then that works. I also have two more theorems for sequences that I want to talk about now. The first one is a squeeze theorem. So if I know that the limit as n approaches infinity of some sequence a sub n is L, and that's the same, also the limit of another sequence b sub n, and I have some integer, we'll call capital N, where I have another sequence which is between A and B for all n, then I know that the limit of this other sequence, where all the terms are between these two, is the same limit as the other two. And also I have the absolute value theorem that says for the sequence here, if the limit of the absolute value of the sequence equals 0, then I also know that the limit of the sequence itself is 0.